Hi guys, I hope you're doing absolutely great so far. In this video, we'll talk about Swift generics. We'll start with learning what is generic after all. And once we know something about it, we'll see what is generic type. That is, we'll see a function and we'll convert that function into a generic function. And that's when we will get to understand what is generic type. Once we know about generic type, we'll see just like function, we convert it into a generic function. How or what all things are there other than function that we can convert into a generic form of it. So we have classes, structure, enums, subscript, initializers, properties, a lot, many things. So protocols especially. So we'll talk about all of them. We'll see examples of them and we'll understand how those can be made generic. Then we will talk about generic constraints. Very important topic inside generics. Once we know about generic constraint, it is basically a constraint that you apply on a generic type so that the concrete type gets limited. Basically means the concrete type that you can use with the generic type will become limited. And we'll see what all this means. And then we'll talk about where clause, which is used to make your constraint more precise. And once we are done with learning these two things, we'll talk about all the protocols. A lot of protocols basically that we can use with generic type and why protocols with generic type usage. We'll understand everything all along step by step. And we're diving pretty deep into this concept. So grab your Xcode and let's get started. So for this video, you would see I've written a lot of things and there is a lot of code I have written beforehand. The reason behind that is this video will become longer if I will type each and everything. And since we have a lot to cover, and if I write the code beforehand, it would be much easier for us to understand. We'll start with section by section. We have 5 sections to learn in this video. The very first is what is generics. So just a short definition would do. And then we'll see an example and that will be the end of it. And then we will go to the second section. Generics in Swift allows you to write flexible, reusable code that works with any data type by defining placeholder for the type. Let's understand with the help of an example. I will write one normal method here without generic type in it. So we have the function add. What I will do is I will bring this comment and comment everything from below. Only about this we will be talking and focusing on, and I'll shift it down when we need to focus on further more code. Now here I will create the add method which will have one parameter, and here I will just print x. Very simple. I'll call this and give 33, and that's it. Let's run it and we will receive 33. Very simple function. Now how do we convert this function into a generic function? So what generic really means is that here I'm printing x in this function. If I want to print some other type of value, so I will create another function. I will name it add1, and here also I will make the change and I'll make add2. I'm not doing any addition, I'm just printing it. But here we have another type double, and then I can access this method add2 and give it a double type. Let's run it and we get values. Now it's a very simple example, and now we are going to see what generic really means. So here we have two functions, both are doing nothing, just printing. And but one function is for one type integer and another is for double. So what we can do is we can make this type generic, that is it will accept the concrete type integer as well and concrete type double as well. That is the value that you pass will be of concrete type integer, will be could be of value of type double. So how to make that? All we have to do is to create here angle brackets and give a generic type. So you can give any name of the generic type we mentioned here, but here I'm giving capital T. This is something very standard. All the coders across the world uses T to represent generic type, and I would suggest you to also go with T as generic type. And that is it. We have made a generic type. Now all we have to do is use it inside or across our function. So here the parameter is of type integer. I'll make it T, and that's it. Our function is generic now. We don't need this function anymore, and I can remove this. I can use add one to pass a concrete type value 33, concrete type integer value, and also I can use the same function to pass concrete type double value. Let's run it and we'll receive 33 and 11.0. And this is what generic really means. This type T is called generic type. Now we know what generic type means. It is just something that we mentioned here, and then we can use it in the function. Wherever we are using a type, we can just replace it with the generic type T. And let's understand concrete type term here. That is the value that you are passing here is having a type. So 33 is of type integer. So integer is the concrete type that is used with generic type T. I will mention here type T. And here the concrete type is double. And now that we know what is generic type, let's understand one more example here. Here we have two parameters and a return type as well. So I've given a generic type T and just assigned the type of the parameters as the generic type, and the return type as well is generic type, and just we are returning X. We will see this why I'm not doing addition here and returning the result, because for that it needs to conform to a protocol numeric. I will quickly show you, but I'll put this here so that the rest of the code is commented, and I will do X plus Y, and let's run it. And it gives us 7. But I will undo this for now. I will remove this. So it's important for us to understand everything in steps so that we don't miss a lot of questions that comes in mind whenever we learn a new term. So we will go step by step in an incremental way. We will learn everything. So here we understand what is generic type, and what we are passing is the value which is of concrete type integer here, that is 3 and 4. So here we understand two terms, generic type and concrete type. Now the question is the values that we are passing is of type, and that type is the concrete type that is going to be used with this generic type. What all other concrete type I can use with this generic type T? So I will write here what all other concrete types I can use with generic type T, and that's the question. So we have seen the values double. We have seen the values double we are passing here. We have seen the value integer we are passing here and here and here. So integer, double, other than that, float, boolean, string, character, you can pass anything, but make sure that we can pass in here, we can pass a string, and here also some other string, and add one will just print it. Let's comment this one for now and run it, and we'll get string, some other string. We have seen integer, double, string. Just like that, we can give character as well, a boolean as well, a float as well. And we will see this question in detail actually, because other than this is just primitive data types. Other than that, there are collection as well, arrays, integer, arrays, set, dictionary. So, but we will see them step by step. So we will address this question in detail just in a while. I will bring this comment down to here. I will undo this code as well. And that's it. Now, what all other things can be made generic? So we have seen functions right here. We can do, we can have a structure as well, and we can convert it into a generic structure. We can have classes, enumerations, subscript, initializers, and protocols. All of them can be converted into generic, or all of these do use generic type. So let's see examples of each one by one. The very first, that is generic function. So although we have seen a function, but let's take a look at one more example. So here, first we will see without generic type, that is a normal function, how it looks like. And then we will look at with generic type, that is the same function, but we have applied generics on it, and we are using generic type with that function. And we'll follow this same pattern of examples for all of them. That is, for structure also we will see a structure without generic type, and then we will see an example with generic type. So let's start with function. In here we have without generic type, that is a normal function, swap ints, and we have two parameters which is taking the value of type integers, and they both are using in out keyword. That means they will be taking the values by reference. So I have created here two x and y variables, and I've passed the reference of x and reference of y as the argument to the parameter. And in here in the logic, I'm just swapping the numbers, and that's it. After swapping, I'm just printing both the numbers x and y, and it should give us the output 20, 10. Let's run it. So it gives us 20, 10. Now let's see this function with generic type in use. So we will use the angle bracket and mention the generic type name here, T, and we will use it for the type of parameters, and that's it. in the body we are not using anywhere, and when we call it, I have created two variables. They both are of type double, and I'm passing here both the variables by reference, and then I'm just printing it. The values will be swapped and then we will print it. Now you will notice before we were just passing integer because it was expecting integers. Now that our function is generic, we can pass double values as well. What happens here? The generic type is T is having a concrete type double values. And let's run it. Okay, I forgot to put a comment block here. And let's run now. And it gives us 11.0, 10.0. That is our swapped values. And that's how in function we use generic types. Let's see next, that is generic structure. So first we will see a structure int stack without a generic type, and then we will see an example with a generic type in use. So here is a structure int stack inside which we have one property named items, which is of type array of integer, and we are giving it empty array as value, and it has two methods, push and pop, and you will see mutating keyword is used in both because these two methods are going to make a change in the property of the structure, that is item. Push is making a change by appending a value item which it is taking in the parameter, and pop is popping the last value in the array. So because these two methods are making the change in the structure, we have to mark it as mutating because structure is value type, and that is all there is. It's a normal structure. Here I have created a object of a structure, and I'm just pushing two values and popping once. So when it is popping, it will pop value 2 and it will print that value as well. So we will receive 2 in the output. Let's run it, and it gives us 2. Now how to convert this structure or how to use generic with this structure is we have to use angle bracket right after the name of the structure. So here you will see element is used for declaring the generic type. Now element is again just another word that we use as a standard. So other than T, we can use element as well. So where do we put the angle brackets? Right after the name of the structure, and then we are free to use it inside the structure body. Here we have the same thing, one property which is having the array of integer. So instead of integer, I have wrote the generic type, and in the two methods we have the parameter of type. We had it of type integer, so I made it element, and here integer optional, so element optional. Now when we are creating the object of the structure, we have to mention the type using the angle bracket right here before the parenthesis, and that is it. Again pushing two values and popping the last one and printing it, so it will give us output 2. So right after this 2 we will receive one more 2. Let's run it, and that's it. It works. Instead of these values I can pass double as well, float integer like that. Now let's run it, and it will give you 21.0. Okay, so we have given the double, but here we forgot to change the concrete type. Here we have to mention double, and let's run it now, and we get 21.0. That's it with the structures. Now let's take a look at classes. So this is how without generic type a normal class look like? This is a class int box, inside which we have one stored property, that is variable stored property, and here we have a designated initializer for it. Simply creating an object and accessing the value, it will return us 101. Let's run it, and it gives us 101. Now let's see how can we make it generic. So here with generic type, I've changed the name from int box to box so that we don't get a redeclaration error when we run it. Just like structure, we will use angle bracket right in front of the name of the class and give our generic type here. And now we can use it inside the body of the class. Here the value was of type integers, so we marked it as the generic type, and the parameter is also having the integer type. We have changed it to generic type, and that's it. Previously I was giving integer, I can give hello as well. Now you will notice here, in here we are not using angle bracket to mention the concrete type. That is because it is optional. The value that you are passing, the type of that value will help in identifying the concrete type that you are passing to the generic type. So basically here the generic type will infer automatically what concrete type is for that generic type based on the value that you pass it. And that's it. Let's run it, and it will return hello here, and it returns hello in the output window. And that's it about classes as well. Pretty simple, right? Now let's talk about enumeration. So here, without the generic type, normal enumeration, how it looks like, we have int result. It has two cases, success and failure. Now you would notice something. It is of it is having a associated type int, and it is having associated type string. And when we are creating to let constant with the values of enum, we access with the name of the enum dot success and give an integer type value that will be taken by the associated type. And here we are passing the string error, that is the associated type string. Pretty simple. I will print them as well. Let's run it, and it gives us success 42, failure error. Now that is how a normal enum looks like. How to make this enum generic? Let's see that. So just like structure in classes, we create an angle bracket right after the name of the enum. In structure classes, we were creating the angle bracket and giving the generic type right after the name of the structure, name of the class, and here name of the enum. Now you would notice there are two generic types we are giving here. Now T and U, and T is given to the associate type of success, and the associated type of failure is U. And when we are passing them the value, the concrete type of the value that we are passing to success is integer, and the concrete type we are passing to the failure is string. Now if failure was also something which was getting the value 42 or 43 integer, then there is no need to create another generic type. We can use the same one, right? Because it's integer, right? After all. And here also we will have to just give like this. But That is not the case. The success is having the associated type integer and failure is having string. So we have to create two generic types, that is t and u, and assign u to this. Now you must be thinking there is always one confusion, that Shubham, why cannot we just use t here and pass a string here like this? Well, the problem is this t is something that we have mentioned here. When we are passing the value, we actually tell the concrete type as well. Now once that is done, t knows that the concrete type for t is integer. Now you must be thinking, why not just not mention here like this, right? Let's not mention at all. Let's run it and we'll face one error, okay, which I've mentioned here. Let's run this. Because we think that based on the value, the concrete type will be inferred automatically and the generic type will know about its concrete type. But that is not the case. T declared as parameter to type result1, that is t. And the second thing it says, explicitly specify the generic argument to fix this issue. Error, generic parameter u could not be inferred. Let's go little up. The very first error it gives is generic parameter u could not be inferred. So what it means is, if we do not specify here the concrete type, t and u will not know its concrete type. And that is why it is must for us to mention here like this. That's it. So if we are mentioning integer and just using t, that is what we were trying to do. The concrete type int is fixed for that generic type and we can only pass the integer type values. If we pass error, that would be string and it will be having a problem. So we have to mention it like this here. Now if we remove it, this is what the error we get. Here I have mentioned the error generic parameter u could not be inferred, which is this. And why is it? So previously in this example, that is class, it was inferred automatically, right? But what is happening with enum? Why it doesn't infer automatically? So for one single type, that is t, it may will infer automatically, but for two types, that is u, it won't. So that is what I've returned as in terms of explanation. So I've written error here and the error that we are facing, and note 1 for more explanation for it. So if we take a read on this node, Swift's type inference cannot determine the type of the second generic parameter u in the enum result1, which is this. While it can infer that the type of t is integer based on result.success42, if we mention only this and do not really mention the concrete type of t, there is no information available to infer the type of u. So let's try this. Let's remove u and give both of them type t, and also here we will pass the same concrete type value, integer. Let's run it. Let's print it as well. Let's run it, and you will see the generic type t has inferred its concrete type based on the value provided. We have not mentioned the concrete type explicitly using the angle bracket here. And you would see in the output success 42, failure 23, which is success 42 and failure 23. So it's only when you give the second generic type here and you are using it here, and here you are using another type, concrete type value here, then you have to mention the concrete type of both the generic types. So I will run it and we will face the error. So let's mention the concrete type explicitly here, and here as well. Let's run it now. And now it won't give any problem at all. And it gives us success 42, failure, error, ABC. That's it. That's it about enumerations. There are doubts when it comes to multiple generic types. We have covered that as well. And we are good to move forward to the next one, that is subscript. So I will copy this and uncomment this much code. So subscript, so this example is where there is no generics, there is no generic type in use. This structure is having a subscript in it, and this structure is not generic at the moment. And the second example we'll see is this structure becomes generic and we make everything inside generic by using the generic type. Now let's see subscript again. Just a quick revision. Subscript is easy access to the collection that we use inside the structure or class. We have learned subscript in very much detail, and if you haven't watched that video, I would recommend highly to watch that video. You will not have any question, doubt on subscript. And here, let's get back to the example. In subscript, we have get block and set block. In the get block, it runs when we are reading the value, and set block when we are giving, assigning a new value. And here I have created the structure object and gave it an array of integer values. Now when we access with the name of the object that is going to be using subscript. So object, and when we do bracket, that is when we are using subscript. So it's an easy access rather than using the object and dot and then the property and then giving the index inside the bracket. We are just using the name of the object and the bracket and then giving the index. This one will go to the index, and it will, since you are reading the value, it will run the get block and will get you the value from the item at that index. When you are assigning the value, it will go to that index and assign this value. This value will be coming into new value and will get assigned to items at that particular index. And that is how you gain easy access to the property items here inside the structure. Now we will see how to make this generic. Okay, first we will run it. And we will see output 2 and 10. So 2 and 10 are the output. Now let's move on and see generic subscript. So this is the structure inside which we have the subscript. The same example as above, just the name is changed so that we don't get the redeclaration error. And same content, that is, we had a property here and we have a property here as well. Here we had array of integer. We just made the structure generic and we gave the generic type t, and we are using it here for initializer as well. And inside subscript, we're using when we're returning the value from this property. You would question here that why we are not using for this integer, because index is going to be always of type integer. Now if we use generic type t for here, it would make sense because type T is basically representing the generic type. So the values of the array could be generic. Here we can give string, or we can give double, float, integer, anything that is something that could be generic. But the index is always going to be of array, that is always going to be the integer. So that's why we are not using T here, just only in the return type. And that's it. That is how you make a subscript generic, by using the generic type. Let's run this, and we will receive B and Z, and we're receiving B and Z. Now let's look at the next one, that is generic initializer. So this is the normal structure container one with a property and a designated initializer for it. This is currently not a generic initializer, and it is having designated initializer is having a parameter input that is of type int. Normally just creating one object of it and accessing that value. Let's run it. We will receive 42, and we receive 42. Let's see how to make the initializer generic. So it is named container1. Here I'm naming container. Same thing inside the structure, one property and initializer for it, the generic type name, that is T here, and just using it for the type of the property and the parameter type. And that's it. Just like I was able to pass the container 42, I am now able to pass it string as well, and just printing both the values. Let's run it. So 42 and hello Swift. That's it about initializer as well. Pretty simple, right? Now let's talk about protocols. Pretty interesting. So first we will see a normal protocol, that is protocol not using generics, so without the generic type. So this is a protocol container 0, inside which we have three requirements. So the first requirement is function append, which is taking a parameter item of type int, and it is using the mutating keyword because if it gets implemented, this protocol gets implemented or confirmed by structure, then structures are value type, and this append method will be used to append the item inside a property of type an array, which will be there inside the structure. So it is mutating that property. That's why the keyword is here. But important thing is the requirement is a method here, a read only computed property count of type integer and a subscript. Now, how do we make this protocol generic? You must be thinking that here I can give the angle brackets and mention the generic type name, right? And then we can use it as a placeholder here, here, and here, and not here because this is the index of the subscript, which will always be integer. But you're wrong. We cannot. This is something we do in structure class enum, but not in protocol. In protocol, we use a keyword called associated type keyword like this, and then we mention the generic type T, and now we can use the T as placeholder here, here, and here. And now it's a generic protocol. I will undo everything because we have the generic type in use here. So associated type T, and then we are using it as a placeholder for the types. Not here count as well because count is always going to be in integer. This is how we make a protocol generic. Now let's see how, when this protocol is implemented by a class, how that class will tell this protocol the associated type, or how will this class will tell the concrete type for this generic type T. So there are two implementations. The first is a class which is non-generic. A normal class is implementing this protocol, this generic protocol. And the second implementation here is a generic class implementing a generic protocol, right? So first we'll take a look at this step by step. So let's understand this one first. Using generic protocol with non-generic class, which is normal class. So we have int container 2 is the name of the class, and it is conforming to the protocol container 2, which is our generic protocol. Now since it is conforming to the protocol, it must implement all the requirements of the protocol. So we have total 3 requirements, and we have that implemented here. This is the first, that is append is the first, count is the second, and subscript is the third. So we know about these three. It is implementation of the requirements of the protocol. Now this is the property, private property items of the class, which is of type integer, array of integers, and it is currently empty. We use the protocol methods implemented here. For a subscript is for gaining easy access to the array, count is for counting the values in the array, and append is for appending the values inside the array. Now here we use this to tell the protocol that the type t is going to be integer. So this is a non-generic class. We don't have here angle brackets and any generic type. So how we do tell this protocol what this associated type t or generic type t will have the concrete type. So we use that here, and with the help of, we don't use it, we just type type alias here, and that would be t, and that will be equal to the concrete type. So here I've mentioned concrete type for associated type. Here we can have that, the question that we generally have, I've written it here, how to give concrete type to the associated type from non-generic class implementing to that protocol. And this is how we mention it. Very easy, very simple. And that's it. We are creating the object of this class here, container 2, and just appending 10 and 20 in it, and then printing the count, that is 2 values are there, so it will print 2. And then we are reading the first index value, so it will use subscript since we are using the object name and the brackets, so it's easy access to the property inside the class. So it will use subscript and give us 10, that is at the 0th index, and the first index will have 20, so it will give us 2, 10 and 20. Let's run it. And it gives us 2, 10, 20. Now let's see if there is generic class implementing a generic protocol. So this protocol is container 3 name. It is just a copy of the above protocol, this one. All the 3 protocols are same. It just I have changed the type name to TS because T will be using as the generic name of the generic type we are using for the class. So this is just a protocol with a generic type, very simple. And the class here is array container, which is generic. So we have, because it's a class, we use the angle bracket right after the name of the class and give the generic type name T here. Now it is conforming to the protocol container 3. It must implement all the 3 requirements here. So append, count, and subscript. And again, similarly to previous class, we have one property here, array of integer. Now integer is the generic type. Now when we create the object of the class here, we are mentioning the concrete type here, int, And this type we will assign here T to TS, which is the associated type. And we will just use the type alias keyword here. So we bind the associated type TS to the generic type T. Very simple, right? And that is how easy it is to use the generic protocols with generic class. And that is all there is. This is a generic class implementing generic protocol, and this is generic non-generic class implementing generic protocol. Very small difference. Here we had no generic type, so we gave a concrete type by ourselves. Here we had a generic type, so we just gave it there. And this generic type will be given here, the concrete type. So this concrete type, when we are creating the object of the class, is given, and then it will propagate to the generic type inside the protocol here. And that is it. That is how easy it is. Now let's talk about generic constraints. Now here I've written the definition. What generic constraint really means is this is a constraint that you want to apply on the generic type. The generic type T that can take concrete type values. That concrete type values could be integer, arrays, float, double, string, character, anything, right? But what if I want this generic type to only accept the values of type integer, float, and double? These three are numeric values, right? A string is not a numeric value. I just want these three types, these three concrete types for this generic type T. So what I mean to say is only these three concrete type can be used with this generic type. And what we're doing here is we are limiting the concrete types that can be used with this generic type T. And that is what constraint or putting a constraint on a generic type really means. And that is called generic constraint. But how we do it? What we do is this three concrete type conforms to a protocol, numeric protocol. And what we do is we make our generic type T, we make that generic type conform to the protocol numeric. So what happens here? Only this three type, which is conforming to the protocol numeric, or any other type which is conforming to the protocol numeric, can be used with this generic type. Because now generic type conforms to the protocol numeric and the concrete type conforms to the protocol numeric, it can be used. And that is what really it means. Let's see the definition. We can limit the concrete types that can be used with generic type. You can use constraint to limit the concrete types that can be used with generic type. Same thing, but in different ways I have written here. The third is constraint ensures that generic type meet certain requirements, such as conforming to a protocol or subclassing a specific class. So this we will understand in a moment, but we understood how we can apply a constraint on a generic type by making the generic type conform to a protocol. And now the generic type conform to a protocol, only those concrete type can be used with generic type which conforms to that protocol. Very simple, right? Now let's start with understanding this thing with examples. We'll start with very simple example. We have here one example without any generic in use. Multiply by 2, and this is multiply by 2 int is the name of this method function. It has a parameter value which takes integer type value and return integer. It just multiplies it by 2. Very simple, right? And this is the method for double. What we do is we call these two methods, give them integer and double values here, and then the result is something we are printing. I will remove this and we will put the comment, we will comment all the rest of the code. Let's run it now. We should receive 5 and 3.5. It will be multiplied by 2. So we will receive 5 into 2, 10, and 3.5 into 2, that is 7.0. So here I've written works with integer, works with double. Now let's go. This is a simple example. Now let's go and use generic, but there is no constraint in here, right? So because we will address one important question before we see generic constraints applied on generic type, we will see something really important. So here there is a function just return, so because it is just returning a value and it is of type generic t. So you can pass concrete type that this generic type accept is integer concrete type. So you can give any integer value, 5 for example. It accepts concrete type double, so we have given double concrete type value. Also concrete type string can be used with this generic type t, so I've given a string here and I've written works. It works for with all three. I've just taken the values, which is the function returning, and printing it. I will put here comment and remove it from here, and it's time to run it. Let's run this function. Invalid redeclaration it says, so let me change its name to, and let's run it now. Because we have given double result here and here also, so that redeclaration error is appearing. Now that we have changed the name, it won't appear, and it will give 5 3.5 string, and we are receiving 5 3.5 and string. Very normal generic function, right? Now you can see that it is accepting what all concrete types. It is accepting integer concrete type, double concrete type, and string concrete type values. What if I want this generic type to only work with first two, that is integer and double concrete types? So what I will do is I will make it conform to a protocol numeric. Why? Because integer and double are the concrete type that conforms to the protocol numeric, and here the generic type t is conforming to a protocol numeric. So what we are trying to do here is the generic type t, we are limiting, we are putting a constraint on it. We are limiting the number of concrete types that can be used with generic type are now limited from 3 to 2. First it was string, double, integer. After putting the constraint or after limiting the concrete type, it is integer and double. How we put the constraint? We make the generic type conform to a protocol numeric, and now only those concrete types can be used with generic type t that conforms to the protocol numeric. And that is it. If you run it now, this will not work. Now I will not touch this example. I will undo this everything, and here I have written that example. So you will see this is with generic type, but in the bracket with no constraint. Now with generic type with constraint. So here I've made it conform to numeric, and I have commented this code. I will uncomment it first, and then we will read these three comments. All I'm doing is I will be printing all the threes. I'm not printing this, so let me write the print for this, and we are good to run it now. So what we should receive is, let's change it value 51 3.51 as string with a string A123. Let's run it. We should receive this 3, right? But because of the constraint, this 2 will be printed, but not the third one. Okay, I forgot to give here the comment. So it is giving us the error. Global function multiplied by 2 requires that is string conform to numeric. Yep. Only the concrete type integer and double conforms to the protocol numeric. String does not. And that is why this concrete type cannot be used with this generic type. So what is happening here? So this generic type, we are applying a constraint on this generic type. We're limiting the number of concrete type that can be used with this generic type. And we are applying this constraint to limit that concrete type by making it conform to a protocol numeric. So only those concrete type which conforms to the protocol numeric will be used. Here, before there was no constraint. So all the three things, all the three concrete type were used with this generic type T. So only float, double, integer conforms to the protocol numeric. So only this will work. This won't work. For this, it will be giving an error. Here it says where T is equals to string. Some suggestion it's giving, but we'll see when to use the where clause. That is the next thing we learn. But let's learn the generic constraint first very clearly. So I have written here work with int, works with double, won't work because string don't conform to protocol numeric. And that is what constraint really is all about. Now let's go up and read this again. Now constraint ensures that generic type meets certain requirements such as conforming to a protocol or subclassing a specific type. Now let's understand what subclassing a specific type really means. Let's see one example. So before we understand that subclassing, now let's understand one question that arises for everybody 99% of the time. What types can be used with generic type T when T with no constraint? So when we write a generic type T when there is no constraint, what all things we can actually give? We saw what all concrete type that can be used with this generic type: integer, double, string. What else is the question? So that is what I have written here. We have seen integer, double, float, decimal. These are called numeric types. String also we have seen. We can give bool, we can give array, dictionary, set, and to answer it by categories: integer, string, the primitive types. Collections, array, set, dictionary is also something we can pass. Custom types, some classes in a structure that is user defined basically. And reference types with closures and protocol types. These are the concrete types that you can use with generic type T. But when you start putting constraint on it, let's say numeric protocol, you make it conform to a numeric protocol. So now you're putting a constraint, you are limiting the number of concrete types only up to numeric concrete types, which is integer, float, double, and decimal. I hope this question is very clear. Now the second question is, we just discussed it. What all types can be used with generic type which has numeric constraint in it? Or what all types conform to numeric protocol? Integer, integer 8, unsigned integer 8. Now this unsigned, all the laterals we have learned in the in the absolute beginner list of videos. There is one video on the data types, and we have seen these laterals in very much in detail. And the next is the float, double, and decimal. That's the answer. Now we can move on to the next thing. Making a generic type conform to a protocol is one way to limit the concrete type that can be used with the generic type. The next thing is subclassing a specific class. So not only protocols, you can use class as well, user defined classes. Let's see this example. So here we have a class animal inside which there is nothing, and a dog which is inheriting from animal. So this is a subclass and this is superclass. I have a function which is generic, and this is the generic type which is used as the parameter type of animal um, parameter. Now this generic type is conforming to a protocol, not really a protocol, but a class animal. So here it is, it's a superclass, right? What does it mean? Only those concrete type we can use with this generic type which conforms to this class animal, which is dog. So I'm creating the object of the dog, and this object is going to be passed to this identify animal function. So output will be, this is an animal of type, the generic type that we are passing here, dog dot self. So it will say dog. Let's run this now. Because we have that uncommented, we might get an error. Because of this, we have to comment it and comment this as well. Let's run it now. Going back to our example, and it gives us, this is an animal of type dog. And going back to the definition, constraints ensures that generic type meet certain requirements such as conforming to a protocol or subclass. So this is something we just understood, and that's it. That is what generic constraint really means. So I hope you understand what generic constraint really means. Pretty simple, right? And now let's move on to one more example, that is, now before we move to the second example, there is one more very awesome question that everybody has. That is, um, when the generic type T can have these many concrete type values, why are we putting constraint on it and reducing the number of concrete type values that can be used with generic type? And the answer is, you can pass all these concrete type values, but you cannot operate on them. So we will see and understand this, that what do you mean by operate? Why we cannot operate on them? I will go back to the very first example and copy it and bring it down there. That is, let's take this one and I will bring it down here. I will write the question first. Now here I have written the question. Since generic type T can have various concrete type values, why do we use constraints, right? So let's understand the question clearly first. That is, the various type means all these types. Primitive types, that is integer, string, float, doubles, character, bool, string, everything. Collections, array, set, dictionary, right? Custom types, structure, enum classes, reference types, enclosure, protocols, any objects. There is so much that you can, so many concrete types that you can use with the generic type T. Then why do we use constraints and reduce the number of concrete type? That is the question, right? So answer is, you can only pass these concrete type values. You can only pass concrete type values, but can't do any operations on them. This is the answer. What do we mean by this? When there is this function I'm calling and I'm giving an integer concrete type values to the generic type, and I am now doing a greater than, or let's say summation, and it will return type T after the summation. When I'm doing this, this is the operation which will not work. Why? Because that is the thing. When we have just a generic type T and it is not conforming to any constraints, we can pass so many concrete type values, integer, float, double, arrays, in fact, dictionary set, right? But you can only pass them, you cannot do any operations on them. So for example, I'm doing plus here, it won't work. It will give me some sort of error. Let's run it and check it first. So I'm calling the add 2, 3 and just 7 is something it should return. Let's see. And it gives us the error. Binary operator plus cannot be applied to T operands. So what it says is cannot be applied to T operands because the operation to happen, that operation, it needs to be sure that the operation can be applied to these types. In the sense, if I pass a string by mistake, obviously this operation will not work, and that is how Swift prevents us from that. And I will undo this, and that is why we use constraint, make this generic type conform to numeric, and now it knows that the generic type, only those concrete type will work with this generic type which conforms to the protocol numeric. So you're good to do operations on them. I can do plus minus operations on them, so just go ahead and do it. Now we'll get the summation operation will happen and we'll get the result. We'll print it. Let's try running it, and we get 7. I will change the values to 41 and we will get 44 and we get 44. I hope this question is clear. So now that we understand why the constraints exist and why we should use them, because the operations won't happen. Yes, we can pass the concrete type values to generic type, but you cannot access them, you cannot do any operations on them. You have to put constraints so that the operation can happen. Now let's take a look at one more example and understand where clause. So this is the example 2. Without the generic, this is how the structure looks like. Int pair. It has two properties, first and second. And here in initializer, we are not we are initializing both the properties. It's a designated initializer, but in the parameter we are taking, it's a custom initializer because the parameter is changed. We are not taking two values of first and second, we are just taking one array. So here you will notice it's an array of integer and we are passing an array. To make this structure generic, first we will make this initializer generic. We will be passing the concrete type array value. So concrete type is array and concrete type value is array of integer values. So let's create this structure, convert this or use generics with this structure. And we will address one question here after we are done with this. So with generic type, first of all, we are creating a generic type T here and we are assigning this generic type to first and second property. Now, when it comes to initializer, we are using a generic type V for our array, and the generic type T has limited concrete type. Why limited? Because we are limiting the constraint, we are limiting the concrete type by making it, by applying a constraint on it. We are limiting the concrete type by applying a constraint on it, by making it conform to a protocol collection. Only the concrete type which conforms to the protocol collection can be used with this generic type V. And now when we are passing the array of string or array of values, array is the concrete type that conforms to the protocol collection by default. So we can pass it. We cannot pass integer, string like that. Those concrete type are not allowed. Let's run it. Okay, so it says value of type v has no member last. Okay, so when it comes to collection, if I make it to bidirectional collection, and arrays also conform to bidirectional collection as well. So let's run it, and it gives us A and D. And that is how we use where clause, where we check the value type inside our generic type and check it with the generic type which we are giving to first and second, so that we can access our generic type v values by using first and last and just assign it to our properties. And that is just where we are using where clause to make the constraint more precise, in the sense not only the generic type which is having a constraint, but also inside that generic type, that is the values of the array, we want to check the type of that as well. It should be equals to the generic type that equals to t, so that the element generic type and the type t, they both should have the similar concrete types, that is a string. So where clause is just going one step deeper and putting one more constraint in the form of a condition here, and that is it. Now I will copy this, change it here. So the question is, why do we use bidirectional collection? You can pass arrays without constraint, but can't access it, can't do any operations on it. Okay, we can move on to the next example. So I will copy this. So in this example, we'll learn something new. Here we are using equitable protocol, limiting the constraint type that can work with this generic type by applying a constraint on it, by making it conform to a protocol equitable. So this type t will be used in the value, and there is a we are expecting, which will be array of that type t. When we compare this to for the comparison operator, we have to apply a constraint here, and then only you can actually equate it. And that is it. We are passing an array, we are capturing the array here, and a value as well, which is 30. Let's move on to the where clause and see some more example of where clause, although this is pretty straightforward. And after that we will come to our fifth section of the video, which is the last section, and we can close this video. Although we have understood where clause in previous examples, but in here I have written the where clause adds more precise constraint to generic types. You can use it to specify additional requirements. If I remove this, so when I say additional requirement, yes, there is a constraint on the generic type in the form of protocols, but you can use the where clause to be more specific. Now in this function, all items match. We have two types, t and u. Both are conforming to the protocol sequence. What is the operation because of which we need this constraint sequence? So we want to apply some operation on type t and u. Here we are applying equals in the where clause itself. That's why we are saying t dot element should conform to a protocol equitable, and we understand where clause. That is done. In here we are traversing onto, so in the parameter we are taking LHS RHS of type t and u. We are passing two arrays here of type integer, both are same, array1 and array2. When we get LHS and RHS, we are running a for loop on it. So what we do, we take LHS and RHS and zip it. Basically You can think of it as tuple. And then we are taking LHS RHS item one by one, that is 1 1 2 2 3 3, and then we are checking if it is not equals, return false, and we are returning this bool value false. If all the values are equal, then we return true. Why it is conforming to sequence protocol? Because when we are traversing onto any generic type, we must make that generic type conform to a protocol sequence. And that's it. We are printing it then. Output will be true. Let's run this. Okay, line 675. I have to remove this. Let's come back to example and run it again. And it gives us true. And that's it. Now let's come to a question. Quite a good question. What all protocols generic type can conform to? So here we have generic type sequence we have seen. We have seen equitable. We have seen bidirectional collection. So there is so many popular one. I have made a category and protocols that falls under that category. So the basic protocols, that is equitable, comparable, hashable, these are basic protocols that we use to limit the concrete types that can be used with a generic type by applying the constraint. And we apply the constraint by making that generic type conform to these protocols. And you know the reason why. That is, there is some operation that you have to do. Okay, so you have to make it, you have to use the constraints. Now collection and sequence protocols is the second category, inside which we have sequence, collection, random access collection. Numeric, we have seen an example of numeric as well. So numeric and arithmetic protocols, inside that there is a protocol named numeric, and floating point is also another one. Codable protocols, that is encodable, decodable, and also there is a type alias that we use, which is type alias codable, which is equals to encodable and decodable. So this is used when we are creating a local model for conversion of a JSON data that we receive in a response, in an API response, and we convert it into a local model. So we use it there. Output related protocols, custom string convertibles, we talked about it in laterals, data types, laterals, and custom debug string convertible. Iterators and sequence protocol is another categories where iterator protocol is there. Lateral conformance protocol, so there is expressible bilateral protocol is there. Foundation protocols, error identifiable optional set, very popular. All enterprise level applications uses these protocols. And error handling protocols, NS copying, view. And this is non-exhaustive list of protocols. It means there is so many protocols, but this is just a group of protocols that is used often. There are protocols in other frameworks, and I cannot um, just name all of them in here, but this is the mostly used, and I would encourage you to explore this, since now you have enormous understanding of generics, generic type, generic constraint, where clause, and that's all you need to jump in and unleash the power of generics. I hope you find this video informative, and I will see you in the next one.